All right, so today we're talking about the law of sines and the law of cosines. Now, these apply to triangles that are not right triangles. We call them oblique triangles. So make a note of that non-right triangles are considered oblique. And so the law of sines and the law of cosines allow us to find different values given a non-right triangle. A right triangle is easy because we know it's opposite over hypotenuse and adjacent over hypotenuse and basically the whole SOHCAHTOA thing. But when we have a non-right triangle, it's a little bit different because what we have to do is we have to find relationships within the triangle based off of the angles on the sides. And so what I'm going to show for you guys is I want to show this relationship here. So the first thing I'm going to do is show you how the law of sines is derived. We need an oblique triangle, and we'll call it triangle A, B, C. A, B, and C, the capital A, B, and C stand for the angles, and the little a we'll put across from angle A represents the side length, and the little b across from angle B represents the side length there, and the little c represents the side length across from angle C. So in order for us to derive the law of sines, we want to find a relationship using the sine ratio. Basically, I split this triangle down the middle, creating a height. The height of the triangle is perpendicular to the base of the triangle. So if I look at, from here, if I look at this triangle, if I look at the triangle I'm highlighting, triangle right there, whatever it's called, the leftmost triangle with h as the height, I can then identify the sine ratio in that triangle. So let's look at that one. So the sine of angle A, sine of big A, is equal to the opposite over the hypotenuse inside the right triangle. Opposite is h, and the hypotenuse is little b. Now I also want to do this on the other triangle, the other side. Let me highlight it green here, this one there. If I look at angle B, I can determine some other ratios. So sine of angle B is equal to the opposite over the hypotenuse, which is little h over a. Now, since both of these equations house a variable, h, the same number, I can actually solve both equations for h, and then I'll have a relationship I can substitute into each other. So on the red equation, for sine A, I'm going to multiply b on both sides. And what I get is this. B times sine A is equal to h. On the blue equation, if I multiply A by both sides, I'll get little a times sine of big B equals h. Now, since h is equal to both of those things, I can actually set them equal to each other. So I can say, hey, look at this. B times sine A equals A times sine B. And I can divide off my little values from both sides. So at this point, I'm going to divide by B, and I'm going to divide by A. So I get this whole thing over here. I get that sine of big A over little a is equal to sine of big B over little b. Now, I could also prove this to you by rotating the triangle. That's also equal to sine C over C. This is the law of sines. So I want you to write it down in your notes and make sure that you've got it memorized even. It's pretty easy. Law of sines. So with the law of sines there, what this will do is allow us to make an equation and solve for unknown angles or unknown side lengths. Now, there is a catch to this, and I want to work a couple of examples and then we'll come back to the catch, okay? So let's start here with this first problem. In order to solve this one, it's asking us to find BC, which is this side length here. Well, I know that I know angle A. I know this is little a and this is little c over here. So what I'm going to say is the sine of A over A is equal to the sine of C over C. And then I can solve that by using cross multiplication. So sine A would be sine of 34 over, we don't know what A is, that's what we're solving for, is equal to sine of 83 divided by 39. That's sine C over C and sine A over A. Now all I have to do, I have an equation with one unknown. The unknown is A, so I'm going to cross multiply across here, and I'll get 39 times the sine of 34 is equal to a times the sine of 83. And I have to get the sine of 83 off of there, so I'm going to divide both sides by sine of 83. Divided by the sine of 83. So now, a is actually equal to 39 times the sine of 34 divided by the sine of 83. So I'll type that into my calculator. Whoops. 39 times the sine of 34 divided by the sine of 83.